I think everybody got into WebAssign. I think there was maybe one person did get into WebAssign. So hopefully those issues have all been resolved. That was a pain in the butt. Not how I wanted to spend my Wednesday trying to figure out what the hell was going on. But that's all right. Again, I want to remind you do have a homework assignment in WebAssign due on Sunday over the first section. If you've got questions, I'm happy to answer them. But remember, don't use the Ask Your Instructor button, right? Take a screenshot of the question and email me directly. Because for some reason, Cengage doesn't like my email. I don't know why. It comes in like 4 days in. So just a reminder, if you've got questions about WebAssign, happy to answer them. But just make sure you just email me directly rather than asking your instructor through WebAssign. Because it just isn't going to, it's not going to work for whatever reason. All right. Any questions at all over anything before we continue on with what we were discussing last time? All right. Well, let's go back into it. So we were talking about domain and range. Talk a little bit more about that today. Finish up with the net changes at the end, and then we'll get into doing some graph stuff with functions. So remember, again, domain is the set of things that you can do what? What's the domain? What are we interested in? What you can put in, and the range is what you get out, right? All right, so this function is h of x equals 5 minus absolute value of x. Remember, again, absolute value of x basically just you put in a number, it takes away a negative if there's a negative sign, right? All right. Any issues doing that at all? Any domain issues at all? No. So what's the domain going to be for this one? All real numbers, and an interval notation again we use. Yeah, so we'll use that minus infinity to infinity with parentheses on either side. Remember, right now there's two big issues that we need to worry about for domain. Can we possibly divide by 0? Can we take the square root of a negative? Right, those are the two big things that we have to worry about right now. We'll see some examples of that here in a minute. All right. So for absolute value, again, we said absolute value does what? It basically takes away a negative if there is a negative, right? Otherwise, it just leaves it alone. So what's the smallest thing that you could possibly ever get out of an absolute value? 0, right? The smallest thing you could ever get out of absolute value is 0. Right? So notice that we're subtracting things, right? If we subtract things that are getting bigger, then the answer gets smaller, doesn't it? Okay. So looking at this 5, if the smallest this ever can get is 0, what's the biggest 5 minus that thing could ever get? 5, right? So what's your range going to be then? So 5 is the absolute highest you could ever get. Good, yep, good. Negative infinity to 5. And then am I going to use a parenthesis or a bracket on the right-hand side? A bracket, because we can actually hit the 5, right? And I think we'll see a little bit better for the range when we start looking at graphs. I think it'll make a little bit more sense. Rather than having to try to reason through it every single time, we'll be able to look at a graph and see what's going on. Is that okay? All right. So in the next few examples, we're just going to concentrate on domain. We're not going to work on range because it's a little bit harder to try to reason through them. We should be able to understand what we mean by domain, what we're allowed to plug in. Range, we'll leave that to looking at a graph if we want to, which we're not going to do today. All right. So let's look at this one's asking us for the domain of f of x equals x plus 1 over 2x minus 3. I just mentioned a minute ago, what two things do we worry about right now for domain? Divide by 0 or root of negative, right? Square root of the negative. Looking at this one, what might there be a problem? Divided by the 0 piece, right? Okay. So if I look at that 2x minus 3, if I set that equal to 0 and solve for the x, what do you get? Yeah, so it would add the 3 over and then divide by the 2, right? Do we want to plug this number in for x, or is that the one we want to avoid? We want to avoid this one, right? Okay. So again, if I want to try to talk about writing my domain, I want to write it in interval notation. If I want to avoid that number, I would have an open circle there on my number line, right? But I could put in anything else. So I could go off to the left forever, or I could go off to the right forever, couldn't I? So if I want to put this in interval notation, how would we describe just this part? What would we write down to describe just that part? Okay, negative 350 to 3 halves. And then would I use a bracket or a parenthesis? Yeah, parenthesis because we don't want that one, right? Okay. What interval would you use for that side? Good. And again, we would use parentheses, right? Now, I'm going to put something in the middle of these as well. But are we okay with where we're getting these intervals? Right? So that's why I drew the number line, right? For this left-hand side here, this is my right endpoint. I don't have a left endpoint, so that's why we're using negative infinity on that side. And then putting parentheses around it. Same thing on the right-hand side. Are we okay with writing those intervals? Because you're going to be expected to be able to write your answers this way. Is this okay? All right. Now, to be in the domain, I can be in this side, or I could be on this side, right? The way we mathematically describe the word or is what we call a union. And so we use a little symbol in between them that looks like a U. That union symbol there just means to be in the domain, I can be in this interval, or I can be in this interval. That's what that union symbol means, is an or. Is okay? Right. Again, I'm not worried about range on this. Range would be a little bit more complicated. We'll see range of these things later on. This type of function is referred to as a rational function, and we'll play with rational functions in chapter 3. All right. Let's look at the next example. We've got g of x equals square root of 14 minus 7x. What can go bad here? A negative under the radical, right? We don't want a negative under the radical. Right? Okay. So we want that 14 minus 7x to be greater than or equal to 0. That's what we want. That's what we need in order to be in the domain. So if I want to solve for x here, we would subtract your 14 over. So you'd have negative 7x is greater than or equal to negative 14. Then divide by negative 7. I have an x on the left-hand side. I've got not a negative 2. I've got a positive 2 on the right-hand side. What do I do with that inequality? I got to flip it because I divided by a negative, right? Remember, if you multiply or divide an inequality by a negative, it flips the inequality. So this says my x needs to be less than or equal to 2. So how would I express that in interval notation if I need everything less than or equal to 2? Okay. Okay, so negative infinity to 2 it definitely is true. What am I going to put on here for my... this one's going to be a parenthesis. That'll be a bracket. Right? Because it says equal to. Now notice if it gets bigger than 2, it's going to make that negative. So in this case, I won't have the right-hand side. So I just have that negative infinity to 2 in this case.